TG. This is lesson 8.3, Algebra 2B. Today's lesson is on rational functions. The objective of this lesson is to be able to graph rational functions and look at special situations that come up when we have to work with rational functions. In front of you, you see, in the front of your notes, you see three examples of rational functions. Now, the formal definition is it's any function that has a polynomial on top and a polynomial on the bottom of our fraction. Now, a polynomial can be a number, an integer, a variable, the product of several variables. It can be a monomial, binomial, trinomial. It can be a lot of things. So you're going to see some very unusual functions and graphs, and we are definitely going to need our calculator to help us graph these functions. The first couple of videos that we go through here with you today will be videos that essentially help you figure out if the function itself is continuous or discontinuous. We're also going to show you ways in which to find the vertical and horizontal asymptotes. Then we'll branch out into some graphing. Let's start with the three examples you have at the top of your page. The question is, first of all, we're going to look at these three functions and determine whether or not the functions are continuous or discontinuous. Now, the graphs above that have vertical asymptotes are considered to be discontinuous, and the ones that don't are called continuous. Now, how do we determine if there's a vertical asymptote? Well, we look at the denominator. We focus our attention on x minus 2. If there is a value that we can put in for x that will create 0, then there's a vertical asymptote, which means that means the function's discontinuous. So I believe there is. So what we can do, if you have to do this, is set the denominator equal to 0 and see if there's a real solution. And as you can see here, x minus 2 equals 0 generates x equals 2 as a solution. We call this the vertical asymptote. Therefore, since it's a vertical asymptote, it's called discontinuous. The vertical asymptote simply means that there's going to be an interruption, hence we call it discontinuous. The second function has x squared plus 1 in our denominator. Is there something that we could put in for x that will turn this into a 0? So we solve this equation, and if you did this successfully, you would end up with x squared plus 1 equals 0. We would subtract 1 from both sides, so x squared equals, let's put that in a different spot here, x squared becomes equal to a negative 1. And then if we have to square root both sides, we get no solutions, no real solutions. Since there are no real solutions in this particular problem, there are no asymptotes, so it's said to be continuous. So there isn't anything that you can plug in for x that will turn the denominator into a 0, which there isn't. It is considered to be continuous. The last rational function has two binomials in the denominator. Let's check it out. Maybe let's just set it up first of all. First thing you do is you set x minus 2 times x plus 6 equal to 0. Ask yourself this question: is there something that we could put in for x that will turn this into a 0 answer? There's actually two values here. X could be 2, or x could be a negative 6. Those two items are called vertical asymptote. Here's a function that actually has two vertical interruptions in the graph. So we would classify that as discontinuous with two vertical asymptotes. So one, you can see, was discontinuous at 2. Second one doesn't have any vertical asymptotes, so we call that continuous. The last one, we basically have two vertical asymptotes, so it would be considered to be discontinuous. Now let's go down here and have you try a couple. 3 potential rational functions there. I would like you to try your best to find out whether it's continuous or discontinuous. If it's discontinuous, find the vertical asymptotes. If and let me know what they are. So hit pause, work those out, and when you come back, I'll show you what the answers should look like. Okay, welcome back. Here's number one. As you work through this, number one, we have the solutions all worked out today here for you. Put that over here. Okay, as you can see, x minus 16 squared is your denominator. I wrote it out twice. Your solution of 16 comes to us right here when we circle both factors and ask ourselves what turns those factors into zeros, and of course there's just one of those in 16. So it's discontinuous because it has a vertical asymptote at 16. Number two, you can see it's x squared plus 3. So let's see what kind of a solution we came up with here. You can see that x squared plus 3 is equal to 0. There are no real solutions here because when we subtract 3 from both sides, we get x squared is equal to a negative 3. And then we square root both sides, and we can't square root a negative 3 unless we get into the imaginary numbers system. So that one is no real solutions, discontinuous. Or excuse me, it's continuous because there are no vertical asymptotes. Anytime you have no vertical asymptotes, it's considered continuous. And then the last one, a little different setup. It's discontinuous. As you can see, we do have to do a little factoring. So you may have to review some of the videos from chapter 4, section 4 when we factored. They're all labeled in Moodle, so feel free to go back and review. But as you can see, we did find a couple of vertical asymptotes making it discontinuous. All right, hopefully this went well for you. Now stay tuned for the second video. In the second video, we're going to talk about horizontal asymptotes. And thanks for watching.